Well, hello everybody, and let us continue in our discussion about reactions. And one part of reactions is this idea of solubility. Good. And so what do I mean? Let's look at this. Consider calcium nitrate. Is it soluble in water? What does that mean? Okay, let's talk about solubility. Now, where does this all fit in? We've got reactions, and we say we have chemical equations, and then we have types of reactions, and under types we have synthesis and decomp and combustion and single replacement and double replacement. And we'll get to all of these. But one important part of understanding double replacement is whether a precipitate forms. Precipitation reactions, okay? And so one type of double replacement is a precipitation reaction, and precipitation reactions depend on solubility. Okay, so that's where we're going. And I'm getting a little ahead of myself. We'll get to these things a little later, but right now we just want to jump ahead so you can get a good foundation on solubility. Now, of course, we need to define some things. Let's talk about some nomenclature. Nomenclature, okay, good. Solubility. I guess I would call solubility what? The degree to which a substance dissolves. Dissolves. Okay, that's a rough qualitative definition. And then under solubility, we have two options. Things are either soluble or things are insoluble. And what does soluble mean? That means what? It dissolves, I would say it dissolves appreciably. Appreciably. Good. What does that mean? Uh, it dissolves noticeably, right? Now, what our book uses as a threshold is that 0.01 mole per liter greater than, it dissolves more than 0.01 mole per liter. Now, you guys don't know what a mole is yet, but we're going to get there. This is just for, a technical thing, I guess. You don't have to memorize that. This is what I want you to understand. If it's soluble, it dissolves appreciably. And what does that mean? That means it will form an aqueous solution, okay? If I have something that is soluble when water is present, it is when H2O is present, it will be aqueous. And in contrast, something that is insoluble means what? Does not dissolve. And instead of appreciably, we can use the word significantly, by a significant amount. Does not dissolve significantly. And what's important to us on that is that means what? That means it forms a precipitate, i.e., it is a solid in presence of water. Okay? So that's what I want you to know. Insoluble implies that I'm going to have a solid in my reaction. Soluble implies it's going to be aqueous in my reaction. Good. Now, how do we know this stuff, right? Because our first question is calcium nitrate, CaNO3, 2, in the presence of water, is that an S or is that an AQ? Well, we have a table, okay? And this is a set of solubility guidelines. This is qualitative, not quantitative. And it's thanks to our friends at Pierce Prentice Hall. And what does this tell us? Okay, we have a group of ions, and these ions are soluble in general. Then I have a group of ions that are in general insoluble, and then I have some exceptions, okay? Some exceptions. Good. Cool. Now, let's see how do we analyze this. So we look over here and I say I've got calcium and I have nitrate. I go back to my table. Do I have anything on calcium written here? I don't see anything on calcium written here. Some stuff down here, but I don't see any major stuff here on calcium. But I do see nitrate, right? And what does it say? Nitrate is soluble. Are there any exceptions? None, which means anything that has nitrate in it is soluble. So that means this is soluble. And if water is present, that means it's going to form an aqueous solution. So the answer to this is it soluble in water? The answer is yes. And so I would write it, if water is present, not that way, how about this way? How about a 2 there? I would say that it's aqueous. That's the way I would represent that in my reaction. Good? Going further. Calcium acetate. You guys do this one, bring me back. Okay, where's acetate on here? Does anyone see acetate? I do. This would be acetate. They wrote it differently than I do. I usually write it CH3COO minus, but that's okay. What is it? It is just like nitrate. It is soluble. Are there any exceptions? None, which would mean we'd say that this, yes, is soluble. And if this were in a reaction where water is present, CH3COO2, we'd have aqueous written by it. If, remember, water is present. If water is present. If there's no water, then it wouldn't dissolve. Next. You guys do silver chloride. Okay, silver chloride. We want to look for silver, and we want to look for chloride on our table. Do I see anything with silvers? No. But what I do see is chloride. Here's chloride. Chloride is what? Chlorides are soluble. Are there any exceptions? Yes, there are exceptions. Aye. Silver is an exception. What does that mean? Well, if it's soluble, the exception means that it is insoluble. So silver chloride would not be soluble. It would be insoluble. And so my answer here is no. No. Next, calcium phosphate. Let's take a look at calcium phosphate. All right, we are going to look at calcium and phosphate. And so let's look at our table. Do you see phosphate anywhere? I don't see it on top. Phosphate. Oh, here's phosphate. Phosphate is in the bottom section, meaning phosphates in general are insoluble. Are there some exceptions? There are some exceptions. Ammonium and my group 1s. Good. But is calcium a group 1? No, calcium is a group 2. So that would mean calcium phosphate is insoluble, calcium phosphate. So Ca, 2 plus, PO4, 3 minus, 3 of those, 2 of those, would be no, it's insoluble. So it would be written as a solid if water were present. Got it? Next, magnesium carbonate. You guys do magnesium carbonate? Bring me back. Okay, magnesium carbonate. We go to our table. Let's look for something on carbonates. Carbonates, what are they? They're usually insoluble, except what? Except ammonium and my group 1s. Where does magnesium fit? It is a group 2. So if it's a group 2, that means it would be insoluble. So magnesium carbonate is not soluble, and it would form a precipitate. Cool. Let's see. Hey, we're almost done. Last one. Ammonium carbonate. Okay, now we should add some things in our beautiful table here. Just some hints. Number one, all group ones, all group one ions are soluble. So anything that has my K, my Li, my Na as a compound with it, those guys are all soluble. And something else that's always soluble, ammonium is always soluble. So we could maybe add those over here. Ammoniums are always soluble, and my group ones with and compounds are always soluble. No exceptions. And that's why you see here, like, ammonium and group ones, ammonium and group ones, ammonium, group ones, ammonium, group ones. All my ammonium and group ones are soluble. Good. So when I come here, what do you see? Ammonium, and I have NH4, and I have 2 and CO3. And when we look at carbonate, what do we see? Carbonates are insoluble except, hey, these are the exceptions, meaning in this bottom half, if they're exceptions, that means these guys are all soluble. Good, so that means ammonium carbonate is an exception, meaning it is soluble. So if water were present, it would be aqueous. And the answer is yes, it is soluble. And that would be all, folks. That's all, folks. Yeah.